The system that exhibit exponential growth increase according to the mathematical model y equal y naught times e to the kt, where y naught represents the initial state of the system and k greater than 0 is a constant, and is also called a growth constant. Consider a population of bacteria that grow according to the function f of t equals 500 times e to the 0.05 t, where t measured in minutes. How many bacteria are present in the population after 4 hours? Well, first of all, we're talking about the population after 4 hours, but we are given that t is in minutes. So we need to change the 4 hours into minutes. 4 hours equal 4 times 60 equal to 40 minutes. So the amount of bacteria present after 4 hours is f of 240, that is 500 times e to the 0.05 times 240. And that equal to 81,377,395 bacteria. This is the rounded number, so this is about. It's estimated to be this much. Next question asking, when does the population reach 100 million bacteria? So we given the amount of bacteria and we need to solve for t. So 100 million equal 500 times e to the 0.05 t. Divide both sides by 500. We got 200,000 equal e to the 0.05 t. Here we have the exponent in the variables in the exponent. So we take ln both sides. Ln of 200,000 equals 0.05 t and solve for t. We get, this is estimated to be 244 minutes. So after 244 minutes, that the population of bacteria will reach 100 million. A 25-year-old student is offered an opportunity to invest some money in a retirement account that pays 5% annual interest and is compounded continuously. How much does the student need to invest today to have 1 million once he retired at the age of 65? Okay, so we start with our equation y equal to y naught times e to the kt. In part A here, we are given y equal 1 million. We don't know what is y naught. We are told that k is equal to 5%. And this is 0.05. Okay. And we were also told t is 65 minus 25. This is 40 years. So then the amount of money that she initially invests will be solved by this equation. So y naught is equal and we get 135 1,335 and 28 cents. So if she invests that much now, when she's 25 years old, then when she retires at the age of 65, she will have $1 million. Suppose you wait until she's 35 years old to make the investment. Assume the same interest. How much does she have to invest to have 1 million when she retires at the same age of 65? Everything is the same. The difference here is T, 65, and she wait until she's 35 to invest. So she only have 30 years worth of investment. So Y naught is still equal 1 million divided by e to the 0.05 times 30, and that is 223,130. Excuse me, 223,130 and 16 cents. Assume a population of fish grow exponentially upon a stock initially with 500 fish. After 6 months, there are 1,000 fish in the pond. The owner will allow his friends and neighbor to fish on his pond after the fish population reach 10,000. When will the owner friend to be allowed to fish? Well, we are not given what K is, so first thing first, we need to solve for K. Well, to solve for K, we know that upon its stock initially with 500 fish, so we know that Y naught here equals 500. After 6 months, okay, we were told here T is equal to 6 months. Then the amount of fish at 6 months is 1,000. So Y of 6 equal 1,000. So I can set up the equation at 1,000 is equal to 500 times e to the k times 6. Okay. So then 2 equal e to the k times 6. This means ln of 2 is equal to k times 6. So then k equal to ln of 2 divided by 6. Now, note that we start with the population of fish being 500. After 6 months, the amount of fish is 1,000, which means it's double. So this K here in this type of problem is called a doubling constant. K is equal to ln of 2 divided by the doubling time. So now we have K. Let's calculate that K. So K equal to ln of 2 divided by 6. So K here equals 0.1155. I can then rewrite my equation at Y equals 500 times e to the k 0.1155 times t. Now I want to find out how long do the friend have to wait for the fish to reach the population of 10,000. I can solve this equation by setting y equal 10,000 equals 500 times e to the 0.1155t. Divide both sides by 500. So 20 equal e to the 0.1155t. I take ln both sides. Ln of 20 equals 0.1155t. This means t equal and that is 25.9. So this is about 26 months. So the friend have to wait for 26 months in order to fish on that pond.